Hello and welcome to another redox chemistry video. Today we'll be covering the application of oxidation numbers to balance half equations. So the beautiful aspect of oxidation numbers, and I cover this in my introduction video, that if I have a common element in my redox equation, the oxidation numbers can actually tell me whether that element is undergoing reduction or oxidation. So when we apply the oxidation numbers to a particular redox chemical equation, and we focus on one particular element, basically when we're observing the numbers from left to right, if they increase from left to right, this means that the particular element is undergoing oxidation, and if it's decreasing from left to right, it's undergoing reduction. So that's the beautiful thing about oxidation numbers. So in this video we'll be covering how to balance redox half equations, but via two different methods. And they're both equivalent, but whatever you like to do, you're more than welcome to solve it that way. So the first method is an ion-electron method, and we're gonna cover that in the first example, and then an oxidation number method. So if you just want to pause the video and just read through that, I will be going through each of the steps when we're going through an example, so I'm not going to read through it just now. So in our first example, we want to balance the half equation of dichromate going to chromium 3 using the ion-electron method. And then lastly, we want to determine whether the reaction is undergoing oxidation or reduction. So dichromate is Cr2 O7 2 negative, and this is going to chromium 3 plus. So what's common to both of these species is the chromium. So in step 1, we want to actually find out the oxidation number of chromium. So from our last video, I can use rule 5 on dichromate to say that 2 lots of Cr plus 7 lots of oxygen is equal to the overall charge of -2. So oxygen is also part of a non-peroxide species, so its oxidation number is -2. So 2 lots of chromium plus 7 lots of -2 is equal to -2. So 7 times -2 is -14. Bring it on to the right hand side, so that's going to be -2 plus 14. So 2Cr is going to equal +12, or chromium is going to equal +6. And then on the right hand side, with chromium, we can use rule 1 to say that its oxidation number of chromium is equal to its charge, which is +3. So in our second step, now we want to actually balance the number of elements that we are calculating our oxidation number for. So in this case it's chromium, so we want to balance the number of chromium elements. So if I write 2 over here on the right hand side, that's balanced. So now we can move on to step 3. So step 3 is going to be adding, or balancing rather, the number of oxygens. So we can see here that dichromate has 7 oxygens, so that means that I have to add on 7 waters. 7 lots of water onto the right hand side. To balance that out. So now with step 4, with step 4 we want to balance now the hydrogens. But now by adding 7 waters onto the product side, there's 14 hydrogens that we need to accompany for on the left hand side. So now we just add on 14 protons. So that's step 4. And then in step 5, we want to actually balance the charges. So the charges on the reactant side is equal to -2 plus 14. And that's going to equal +12. And then on the right hand side, all we have is 2 lots of 3 positive charges. So that's going to equal +6. So what we want now is to add, or rather, add negative charges to the highest number so that they're equal. So what I'm going to do is I'm going to take 6 from 12, and this is essentially adding 6 electrons. Just write this up so far. That is what we got from step 5. So for step 6, now we have to balance all of the elements. So we've got 2 chromium on the left hand side, 2 chromium on the right, that's check. We've got 7 oxygen on the left, 7 oxygen on the right, that's another check. We've got 14 hydrogen and 14 hydrogen on the right, so that's a check. So we're going to give that a big tick. And then in 7, all we need to do is add in state symbols. So dichromate is going to be a salt. Protons are going to be in solution. Electrons, doesn't matter. For chromium 3 ions, that's going to be in solution. And then water is a liquid. So that's the ion-electron method. And notice that we've actually added 6 electrons onto the left-hand side. So this means that this is a reduction. Half equation. Okay.